Welcome back. In this video, we continue the example series we started on Green's theorem earlier. This time around, we are going to be evaluating the integral we deal with, but this time around from a straight line joining 1, 1 to 1, 2, and then from 1, 2 to 4, 2. That's what we'll be considering. As always, make sure to like, share, and subscribe, and turn on notifications so you do not miss any of our videos. So let's begin. The very first thing we want to consider is how we can break that integral into two. In this case, we shall rewrite the integral as the integral from 1, 1, of course, to 4, 2. That's always been our I, x plus y dx plus y minus x to y. However, we can now split it based off the two lines we have as integral from 1, 1 to 1, 2, x plus y dx plus y minus x to y to the integral from 1, 2 to 4, 2 of the function, which of course still remains the same. Now this is interesting because based off this now we can now evaluate what this integral will give us. So now let's see. On the first part of the line, you have 1, 1 to 1, 2, right? For 1, 1 to 1, 2, you notice first and foremost that in that case the x value is fixed, right? It's not changing, it's just 1 to 1. The x value is fixed. So if the x value is not changing, then it means that in that case we can just see the equation of the line is, so we can say that for I1, which of course will be 1, 1, 1, 2, x plus y dx plus y minus x to y. The equation of the line in this case will be x equals 1, which would immediately mean that dx will be equal to 0. Y, however, is changing values in this regard. So we have the y changing and then x is fixed, so dx becomes 0. That will make some effects or some effects on this function as well. On the other regard, where we have for I2, we would have that in this case, in the case of I2, what we would have is that the integral is from 1, 2 to 4, 2. So we notice that the y value is the one that is not changing in this regard. So if the y value is not changing, it means that would have that the equation would be y equal to 2, which would mean that the y will be equal to 0 in this case. So if we put this all together, then it means that our total integral can reduce. So I can reduce to the integral from 1 to 2. X is 1, dx is 0. So dx being 0 means this part vanishes and this part remains. So you have y minus 1 dy. And then on the I2 part, y is 2, dy is 0. So the y part vanishes. The y vanishes and then the y returns to 2. So you have the integral from 1 to 4, x plus 2 dx. So these are the only surviving members of the integral. So we can decide to evaluate this. So that the I would be equal to, in this case, have y squared minus y, of course this is y squared over 2, minus y, evaluating the integral from 1 to 2, and then on the other hand we'll have x squared over 2 plus 2x, also evaluating the integral, this time around from 1 to 4. So what do we have? It means on this side we're going to have 2 minus 2, then lower bound 1 over 2 minus 1, and then on this side we're going to have upper bound 4 squared, that is 8, plus 8, and then lower bound on this side is going to be 1 over 2 plus 2. That is what we're going to have. So if we put it all into perspective, 2 minus 2 gives us 0. This gives us minus half. This gives us half plus 16 minus this evaluates to 5 over 2. So we know for a fact that 1 over 2 minus 5 over 2 is already minus 4. This is going to give us minus 4 over 2 on top. So that's minus 2. So in this regard, you can see that I is simply equal to 16 minus 2. Because 1 over 2 minus 5 over 2 is minus 4 over 2. That's minus 2. So it means that I gives us 14. So you see that on this part where we have two straight lines, connecting straight lines, of course, 1, 1, 2, 1, 2, and then from 1, 2 to 4, 2, what we have is that the integral is 14. So you see that across the different pathways we pick, our value or the value of the integral has been different. So now, to complete the question, we have yet one more part to consider, which is the part of the curve. And we'll look at that next. As always, make sure to like, share, subscribe, and turn on your notifications so you do not miss any of our videos.